Well, good afternoon to everybody. Thank you for being here to just chat about the challenge of the new design automation. And well, the title is probably more challenging than normal, talking about open source in design automation, so making few people excited. But the real thing I wanted to chat about is I'd like to look at what is happening in design automation when Moore's law, as we see today, is slowing down. And in order to think about that, I was thinking we should probably start thinking on accepting that it's slowing down, and decide if it slows down, what is going to happen. Okay? And I'll tell you, I want to introduce my partners here in 2 minutes. But fundamentally, what I'm looking at and what we're looking at, all of us, we're looking at the slowdown of the geometric shrinking, and we wonder what is going to happen. What is this industry going to serve, and what the new requirements are going to be coming out of a different evolution of the nodes. See, what was kind of easy for design automation in the past, because since a new node was going to come so quickly, it was practically impossible to have a sophisticated tool for the new node. All you have to do is just come there with something that kind of works, and be sure that people will take it and you'll make it work while the thing is still going on. And it was great, because it was very tough, it was incredibly demanding, but when that thing slows down, the dimensions may be different. And that's what I wanted to chat about today, and see whether there is a slowdown of the industry, or whether it's just a slowdown of one dimension that creates opportunities in different dimensions. And we see what people think. Okay? Here with us is Warran Savage, that when we organized this, was CEO and founder of IPextreme, and turns out that things move quickly. So now he's general manager of the IP division of Silvaco. Next to him is Mark Templeton. Mark Templeton, as you know, was the founder and CEO for years of Artisan Components, was on the board of ARM for years, and is now an investor on Scientific Vision. And a new operator in the industry that used to be making all of us happy by taking us public, Mike Wishart. He was with Goldman Sachs. Now he's the CEO of a company called eFabless. And I would like to just ask them to start talking about the new dimension, whether it's IP, whether it's whichever dimension they see, the change from designing the chip to design the system, the change from big design teams to small design team, whichever way they think they like to look at the evolution of the industry and show that this industry is vital, is going to be even more vital in the next years. Warran, would you start, please?
Sure. Well, I think I have a little bit of a different take and perspective on semiconductor than some of the other folks here that were more involved in the technology side of things. I come from a systems background where we're building systems out of chips, and eventually I moved into IP. And as I've seen the IP industry move and the semiconductor industry move over the last 20 years, I think the analogy we think about semiconductor is not a technology problem, but a content problem. Mm-hmm. So my analogy of semiconductor is it's more like the record industry than a technology industry. And people differentiate themselves by what's recorded on the vinyl versus the vinyl itself. And it's not about optimizing the vinyl or the plastic of your CDs, but it's what hit records are the designers putting on that. And so I think that is where I see it happening today. And I think there's such an explosion of diversity that is coming, I think driven by the slowing down of Moore's law, that some of these older nodes are coming alive and being differentiated and allowing new types of applications that are very, very inexpensive applications for in-body applications, in automotive, wired households. And I think as a result of that, it really shows that there's going to be a diversity of IP like we've never seen before. That you're not going to be able to go to school and study this particular topic and you're going to build IP on that. I think that expertise in that particular area is going to come out of a systems area with specialists in that system area that'll know about that. And again, it goes back to the music industry. There are specialists. Your rap specialists, your soul specialists, your rock specialists. And those people don't go to school for that. It comes from their life experiences, companies they've worked in, that will translate that experience into semiconductor IP. And I think that's what's exciting to me about this.
Thank you. By the way, can everybody hear? Is it okay? Mark, what do you think?
What do I think? I think it does feel like we're seeing a slowing of Moore's Law, and I think that's interesting because it's been a long time since that's happened. And people doing design, chip design, system design, they need a way to differentiate their products. And so I think what they've been doing is sort of grabbing onto that next node, praying, hoping they can get better performance quicker than the next guy. But if the node's going to stay around for a while, I think people are going to want more variation within that node. And I think that's what's going to challenge everybody. If you've got a node that stays stable for a few years, from a geometry point of view, people are still going to want to optimize it for an IoT edge application or a high-speed a data processing application or whatever. And I think we're going to see a lot of fragmentation in these markets for the processes. And so where in the past, for each node, we've needed a few different sets of IP to support maybe a low power design, a high performance design, whatever, I think we're now going to see a demand for a very large number of variations of IP, and not just IP, but design kits, PDKs, and even design tools to support these different needs as the process sort of slows down. And I think that's a big problem for people. It's actually a challenge because you're not going to be able to build a piece of IP for one of these variants and sell it 10 or 20 times. You may sell it once or twice. So I think we're going to see some of these businesses look a little bit more service-like than they have in the past. At Artisan, our thing was putting out a piece of IP, getting it to 1,000 design teams. Can't do that anymore. I think if we're going to see a lot of process variation, maybe you can get a piece of IP out and get it to 3 design teams, or a PDK now for 1 or 2 design teams. And that's going to change how people can budget for verification, for running test silicon, for all of this stuff. So I think it's going to be a big change just supporting these variants.
So it's almost like we're moving from a nice horizontal structure. Here is the fab, here's the design. This is done. You just design on top of it to more vertical. Back again on the virtual IDM. Wow. Mike, what do you think?
Well, I agree.
Give me another dimension.
Well, and I think on that concept of the vertical sitting on top of it is, as Warran was indicating, the design itself, the design and the designer. So our company is a crowdsourcing company where we connect a community of independent chip people, chip designers, with people who need chip capability. And the co-founder is a fellow named Mohammed Qasim, who's here today. He's a visionary out of TI. And our whole premise was that we're moving to a very, very different world, that hardware wants to innovate. And you see it, if people have been to the maker fairs, you've seen that. Hardware wants to innovate. And when it innovates, it is an Internet of Things. It's not an Internet of PC. It's not an Internet of phone. It's an Internet of lots of unique, separate things. And we believe that the chip industry needs and should be part of that. Because if you're not part of that, if you're not helping people make things that are unique for unique needs, then it's passing you by. The problem is, each of these items is very specific, and it's a lot like what Mark, what you were saying, the IP may be used a couple times. Well, people don't know how often something's going to be used. So the conventional semiconductor model of cost justifying against a standard product is getting harder and harder to do. Well, this crowdsourcing is used in a lot of different industries, and it does 2 things. It brings the creativity of a whole community together, and that creativity helps people solve problems. And there are other elements that are just natural to crowdsource, and that gives you a much more cost-effective model. So our approach, we don't want to lower the cost of design across a life cycle. We don't think that's where we want to go. We don't think it's where you guys want to go. What we want to do is take the cost of innovation and take that as close to 0 as you can. And then what we'll do is we'll share in the prosperity that comes out the other side. So
we're really saying that the fact that we have the Internet of Things as a platform, and the Internet of Things as a, I like to call it a new country, as a new society. So society, instead of being, used to be people, became computers, became phones, and now it's things. So if you have this new society of things, what I hear you saying is that the entire paradigm of development changes. Who develops changes. What are the constraints to develop change? And thinking that all you do is silicon, that's not the case. As you were saying, you do systems. System may be very small. System may be very oriented to one application. So that's what we're talking about, isn't it? That's, so can we comment on more on what would be then the structure of the design automation demands in this industry? I mean, it's clear probably that saying that all we do is complex chips is little limiting. So where should design automation go? Mark, where should we go?
Oh boy. It is going to be interesting. I think if we look at Mike's world, which I think makes some sense, if we think about there being a need for this huge variation of design, huge variation of content, where is that going to come from? Well, a community makes sense, right? We see that in software. We see things like GitHub, where there's a community of just hundreds of thousands of developers. You can find anything you want there as a starting point. And maybe we need to head in that direction, but it is very challenging. It changes the industry. For example, if you want to develop a complex piece of IP as a community member, where do you get your tools? You're probably not going to call the Cadence salesman and say, give me a bid for $1 million tool here, right? And I think another problem is, if it's in the analog space, you have to work with the foundries. How many of you work with TSMC? Anybody? A few? If you call TSMC and say, hey, can we get a set of design rules to your latest process technology, it takes about 12 months if they love you, right? It's a very difficult thing to do. And if we're thinking of a community supporting this, it changes how foundries have to look at design. We need foundries to be much more open to support these variants. We need tool companies to have models that fit this world better. And I don't think it's impossible at all. When we started Artisan back, it was in 1991. We needed a design rule set from TSMC back in those days. I don't remember the geometry. It was a larger geometry. And we called them and said, hey, we need your design rule set. And they said, what's your fax number? No NDA. It just came across the fax. And that was when a design rule set was like 20 pages, right? Today, it would not be practical. But it was a very different mindset because process wasn't the differentiator. It was supporting this community was the differentiator. And maybe we're going to move back in that direction a little bit.
So we are seeing a lot of this right now. And it's just so interesting to hear what you went through, because in community design, to make all of that stuff that I said work, you have to take the design part and allow that to happen in a frictionless, costless way up front. And then the foundries have to play ball. And so what we did on the upfront part is we have a set of open source tools. We use Electric to Magic, we use ngSpice. And in fact, today, the fellow who maintains all of Magic, a guy named Tim Edwards, has come and joined us because he likes to see a model that can actually make this work. The foundry side we have a partner, XFab, and they have been a wonderful, patient fellow journeyer with us for 2 years. And they worked their way through this, and they understood that by controlling the design environment inside of our site, we can obfuscate all the underlying technologies. So that reason for them to be concerned with the NDA goes away. And so now they look at it as a business principle. Now we as a foundry can get IP on demand, and we can serve all these little customers that we can't afford to serve otherwise, but may one day be big. But it was exactly those issues. We had to address the concerns at the source.
That's interesting. The open source in this case, correct me if you think I'm wrong, the open source in this case is simply a way to give something to a broader community. So it's not cutting down anything or reducing any other previous business. It's just suddenly expanding it. And
we think we're opening up a different market.
The way I like it as a comparison is when we had the software developers for the PC, and you had those 5 companies, maybe 10 companies developing software. And then a different platform comes up called the iPhone. And suddenly you have 10,000 people developing software. It's completely different. So in a sense, if we see this moving from making a 10 billion transistor chip the only important thing to making general systems for mankind, not for one specific application that is well known to be very important. If we move in that direction, maybe the entire thing changes and the requirements are not going to go down, are going to go up.
Right.
And I think that's also true on the system side. I mean, there is a reason why EDAC moved from EDAC to ESDA and the Electronic System Design Alliance, because that's the new driver are the new systems. And isn't that what is happening in IP today?
To some extent, I think that's right. I think what Michael was saying is already in place in the FPGA market. It's been there for many years, and for the same reasons that Mark has mentioned with the early days of TSMC. They have a motivation around getting more designs on their platform. And so I see this verticalization in the design community as one important thing that has to happen to achieve this vision, because the way the market is structured today, it doesn't really facilitate that. There's no roadmap for a GNU set of IC design flows, and it's not going to happen with patents and everything else in it. And that's the big difference between the hardware and software world. That analogy is not going to work exactly. So there needs to be more of a financial incentive on the semiconductors side to get access to this huge market that could be available with greater design content.
Yeah, but every time I see a market changing that dramatically, the structure that delivers products from the new developers to the new market has to be created.
Yes.
It's not going to be exactly the structure you had yesterday.
It'll never be the same. That's right. It's not an evolution, it's a revolution.
It's a significant change. That's
right. That's right.
Any questions? I know that there's a person with a question. How do we get the microphone to you? Is there any way that we can get people to ask questions and be heard?
Here we come.
Thank you.
So you said you don't think there's a GNU toolchain flow for integrated circuits, but I mean certainly there are products like Verilator, Yosys, GHDL, but I think one of the big differentiators is that they have single maintainers and not large corporate sponsors behind them. If you look at like GCC, this is not a bunch of guys in their basement writing GCC. This is largely corporate entities contributing to these things. So do you think there's a way forward that we can get large semiconductor companies to care about these open source tools?
That's definitely an opportunity. And I think certainly the people in the audience, you probably are thinking, gosh, my company, we could never adopt something like this because we have standard flows, we have standard everything's, right? We have standard PDKs, stuff has to fit. It has to fit into our world, right? And I think as Lucio points out, in the smartphone space, we had Apple, and Apple sort of created this world that application developers could fit into, and that let 10,000 people develop software where you never could have done that before, and all that software could work together. There was some minimum quality expectation. There was some screening process that Apple did, and I think that's a big opportunity here, right? There's an opportunity to step up and create kind of that base platform that people feed into, and I think to some extent Mike's solving part of that problem for sure, but we're going to need to have a way to bridge between sort of a community of developers and what big companies need to get their job done. Yeah. And so it's an opportunity.
I think a great example of this, I think that's modern, is what ARM has done with Lenaro.
Yep.
So there's a software community of open source that is organized by somebody that cares about that, and it's funded by their key customers that need a stable platform that they can produce stable software for their customers. And there you have, I think, a model that might make sense for the EDA world.
Yeah. We're seeing, already. So again, our goal is not to serve the people who are already served. We think it's very unlikely for all those folks who, in the traditional company environment, are going to come and adapt us anytime for the foreseeable future. And our plan is not built around that at all. We think, like other markets, there is a tremendous amount of inherent creativity that is out there that is not allowed to happen. And in these new markets of emerging hardware, you're seeing companies and groups and individuals emerge who do not have that connectivity to the electronic expertise to turn an idea into an optimized outcome. It's basically that world that we're starting with. And I'm sure it's going to start very small. As the community grows, the expertise within the community grows, it gets bigger. But I think it'd be a very bad bet to say that at the end of the day, semiconductors is not going to innovate like other markets innovate. I don't think we can predict how it's going to look when it finishes out, but we do believe a community is part of that. It's happening everywhere else.
Yeah, but also very likely we're going to find out a different segment of the industry are going to create a different set of communities and a different ecosystem for them. And the
Right.
ecosystem for the pharmaceutical industry is going to be different from the ecosystem for the automotive industry when it comes down to bringing more and more and more of the Internet of Things into these different segments of society.
And those communities can communicate between one another very, very easily.
Any more questions?
My name is Rahul. More than a question, I wanted to ask you guys your opinion.
Close to your mouth.
I wanted to ask you guys your opinion. Instead of reinventing the wheel by having a GCC-like toolkit or environment for open source development, why can't we have something like a timeshare where EDA industry just contributes all their tools through a crowdfunding mechanism, and then we timeshare the tools that are already out there, where nobody has to give up their revenue, and on demand basis we can add more licenses, and and that way we can create an open model. What do you think?
Well, I think we're talking about a lot of different things in this panel today, and we're talking. There's different kinds of open source, different kinds of community. I think we can imagine software being open source. We can also imagine IP being open source, and even full chip designs being open source. So I think, in some sense, we're not really talking about cannibalizing the existing industry. What we're talking about is a new vector for innovation that we think is going to happen as we see these markets sort of fragment, as we see smaller, more specialized markets. Some of these people may not be able to afford design tools. So I think that may push some of these companies more towards Mike's model or to an open source model. But in terms of the big EDA guys being time-shared, I don't know. I'm not sure this really cannibalizes their business. I think it's more additive to the IC community, as a whole, really.
I don't think our model is going to be any cheaper for the inventor than what they have today. So lowering the returns to the EDA industry is not our goal at all. We just want to get the cost to get the innovation complete as low as it can, and then we share later. So we don't see it as, we see it as growing new applications and the pie within that growing.
Yeah, and the point is, while it's absolutely true that some of these things will be using exactly the same tools, therefore might be just a matter of sharing versus buying, a lot of the application will be completely different. And the requirement for tools will be different. And not just for the application itself. I mean, it's not going to be enough to have the tool for the silicon. You're going to want the tool for the memories, the memory design. You're going to want a tool that allows you to do quick prototyping with FPGA, and then move that to SoC in a very, very soft way. You're going to have different kinds of tools for responding to a new set of requirements for security. There's going to be so many different things that are going to be evolving. Once you evolve and you explode the number of applications, and you start getting this billion and billion of things talking to billions and billions of things, who knows what kind of real tools you need to design those things. I don't know. And
so to add on to that point, specifically to your question about timeshare of tools, I think it's a good question. It's been around for a long time. And I think it really comes down to, I think the topic here of what's the market elasticity associated with the cost of tooling. If the EDA companies would see a significant increase in revenues by, as Lucio says, an explosion in the amount of designs being done, then as long as they see their revenues grow as a result of the market exploding, I think they would be open to it. But that's not what we've been seeing in the last 10 years. And I think it's like the Big Bang Theory. The world collapses on itself to a point where it's stuck, and then it explodes. And I think we're reaching that transition?
It's going to be, we cannot see how the community will be, but will be different, and for sure it will be different. There is different requirements, they're the pull from a different market, and the dynamic is there, so it's going to be an exponential requirement of things that we don't know. If I knew, I would be investing in every single one. We don't know. Yeah. Any more questions?
Hello. How do you think that the EDA industry, by providing open source tools, how can they profit more in this kind of business, like inspired in the software business that they have open source from GCC, Linux, and other kind of stuff, so migrating this kind of business for hardware, for EDA tools, so how do you think that they can profit from this kind of business?
Well, go ahead.
I would say that we need to see more of a royalty model that ties back into the EDA, where the EDA companies have a stake in the success of the products that are from the products that they're being used for. And I think if we can have a model where the success of the chip is tied to the quality of the tools, if the customer's successful, the EDA companies are successful, and the EDA companies are going to want to place a lot of bets.
We used to call it the IP model. Now the point is, to make it very clear, I don't see that the traditional tools and the traditional segment of the industry is going to disappear at all. The new nodes still are going to be there. You're still going to be trying to get this more sophisticated thing. There is going to be lower power that you did not expect, and now you need to find out a way to solve that. So the problems that are being solved will still be over and over repeated always. The point is, you get a community with different kind of variables in front of them. They cannot use the old business model. It just doesn't work, doesn't apply. And that's where it's going to be incremental and not decremental. This is going to be more opportunities, not less. That's the way I say it.
Yeah. Yeah, I was trying to wrap my head around who you were referring to that is the underserved market. I think you're talking about designers. So are you talking about designers that have spare time? Or are you talking about designers that are at small companies? Or are you talking about designers that want to do something after hours? Would be question one. And the second part is that, as you probably know, there's many more software developers than there are hardware engineers.
Sure.
Many more orders of magnitude. And had you considered in pushing this innovation, somehow addressing getting the software content development aspect into hardware as a part of this model?
Sure. So let me separate this. So the first one, underserved market, and then needs of designers. Those are two separate ones, and let me break them apart. To us, the underserved market are all of those places where people cannot get semiconductor expertise either today or in the future. So one example is there are certain nodes that foundries want to bring up where they can't get enough, because it's just niche enough or specific enough where they can't get the level of service in a conventional way. This becomes a way for them to fill that. But in the big market, the market that we're really targeted at, is we think a tremendous amount of innovation, this next generation of hardware, are going to come from organizations or individuals who don't have internal electronic capability, and because they're hardware, they should have that. And so that ability to connect a multitude of ideas, no one of which you could have a probability of success on, with somebody who's going to solve that is unfilled. They can't pick up the phone and call a semiconductor company and say, hi, I'm Joe in Topeka and I have this idea, can you help me work this through? That's one side. The other side is the designer needs, and you actually hit the nail right in the head there. That, from our standpoint, the designers are individuals and small groups. That's who we think is going to collectively make up the community. And as we talk to them and others talk to them, the predominant need they want is the ability to get to business that they would never otherwise see.
Yeah. And it's interesting because these communities are really there now. I mean, I was looking at just social changes that are happening in rural countries in Europe, where people that used to just leave their little town and go to the main town don't do it anymore. They're well connected to the internet. They connect with everybody, and you know, maybe you're gonna stay in your own society where you could fit very easily, and you're gonna be one of the team of 4 people that are just designing something for a mechanical industry that wants a sensor, they don't know how to do it. Who knows? But fundamentally, there is the number of engineers that are coming there, and they would rather not have to move their life, go somewhere and work in a 10,000 people company, go there at 8 o'clock and get a cup of coffee and go sit down. It's a big number, a huge number. And I think the industry is now required to move more flexibly via IoT and via this new country, which is the Internet of Things. It's going to be completely different. And people will be able to contribute in a much more spontaneous, natural, and socially positive way. So that's the way I see it. Any more questions? Please.
Yes, so I'm hearing 2 very different statements here. I'm hearing Lucio say that the traditional markets will not go away at all. And I'm hearing Warran say that the universe is going to collapse on itself and then explode into indescribable new bits.
It's a panel, baby.
It's a panel.
It's a panel.
Thank you for the, thank you for the entertaining diversity of opinion. Warran, what is the new universe going to look like after it's collapsed on itself, which probably has already happened? What is it going to look like after it explodes? What are all the bits going to look like? What are the new molecules and atoms and et cetera going to look like in this new universe? But be honest. Don't be politically correct.
Okay,
be
I
honest.
won't be politically correct. It's going to be huge. It's a joke. So, when I talk about exploding, I'm talking about the amount of design content that's available to be put on silicon. And I think, you know, we see so much in our industry of consolidation. Semiconductor companies consolidating, EDA industries consolidating, IP companies consolidating. And I think to a point, I think what's different about design and IP and specifically is that this is not going to follow the same trajectory of collapsing into itself to a point. And instead, we're going to see the IoT market, automotive, and those industries there's going to be many, many new applications that we can't really envision today that is going to require new design content that is not going to be USB, PCI, DDR controllers, those type of things. They're going to be functions that are going to be very specific. And I think as someone said here, I think Mark, there might be just 1 or 2 applications for that technology in the world, but there will be 1,000 of them.
Yeah. You know, one of the things that Mike said, I think that was most important is this notion of bringing community to this. And if we look at, you know, like it's worked well in software, it's worked in other industries. And certainly if you look at software development has changed fundamentally by community. You know, when you say, hey, write this code for me, what is the first thing the guy does? He goes to GitHub. Is there a starting point, right? Yep. Is there some stuff I can learn from? Even if I'm not going to rip it off, I just want to learn how it works. That's a huge change. And not only can you go to GitHub and find a few things, you can find a few million things. The variety is staggering. And so they say, well, what's happening in hardware innovation? Well, who's been to Maker Faire, right? That's a community. Maker Faire was in San Mateo last week, or week before. My brother and I went. There's 150,000 people attended. The variation was unbelievable. It's a Darwinian process. That variation, that innovation needs to come here, right? We could use those new ideas. And in their space, in the Maker Faire space, no company says, oh, this is cannibalizing us. It's quite the opposite. You know, you go to Maker Faire, it started off as this community of sort of crazy hobbyists. Now ARM is there, NXP is there, you know, Avnet's there, IBM's there, Microsoft's there. You know, it's a nexus of innovation driven by community, and it's super, super valuable. And I'd sure like to see us get a piece of that action.
You know, from that point of view, the two positions were not really conflicting. They are just shedding light on 2 different aspects. Yeah.
So one of the things that makes this a little bit implausible to me is that semiconductor manufacturing is inherently a mass production process. So if you look at something like Maker Faire, I agree completely that community, and But imagine what Maker Faire would be like if you could only build 100,000 of something, a minimum order, before you can't tinker around and build one. You have to build 100,000 of them, because that's kind of what semiconductor manufacturing is like, and that goes along. That drives a couple of things. One is you've got to address a market that's going to consume a reasonable number of these things. You can't build a semiconductor. You can use FPGAs, okay, but without that wrinkle, you can't use semiconductors for building something where the market may only turn out to be 100. It's just too risky. And inevitably, the cost of even doing the most trivial semiconductor design in the most antiquated process you can think of is still very high, much higher than the sort of costs that are involved in throwing together something at Maker Faire.
Can I take this for a second?
Sure.
I agree completely with you that the semiconductor has not changed the requirement of volume in order to be cost effective. But the key point is, in fact, exactly that you have to stop thinking that the only way to innovate is to build 1 million chips of 1 billion transistors each. It's not that way. We need to start thinking not about just design automation for chips, but design automation for systems. It's tool for systems. And that means there's going to be tools for somebody that is going to make only 5 or 10 prototypes. But out of these 100,000 people, maybe 10,000 are going to be ending up with something much bigger. And maybe 100 will end up with something in the hundreds of thousands. And they will never have gone there unless they were in this community where the entry price is low. And you're a creative person, you can do something and you might fly high. Remember, the entry price of the personal computer was very low, was an hobbyist game, okay? It was an hobbyist game. And I think that we're going to find these things not anymore just in the computer field as personal computer was, or in the telecom field like the phone was. We're going to find this in other fields. We're going to find this in medical, for sure. We're going to find this in mechanical, different segment of mechanical, in the car industry. So there's going to be a lot of innovation that's going to go there, and maybe initially will be just an FPGA with a little pieces of IP that somebody buys and puts them next to it on a substrate, because that's the only way to make something viable. But eventually, many of these will explode and will be the new leaders in the industry. That's the way I see it. Any comments?
Agreed.
Okay. Another question here.
Any more questions? One more question, if we can.
Yeah, Lucio.
Please.
So what am I missing there? Because you almost answered the question I was going to have. It sounded to me what we want is simpler, cheaper, configurable platforms, whereas FPGAs are a little too complicated. We need stuff which is programmed from software, which actually you can build just 5 of rather than 100,000. And isn't it like something a bit smarter than an FPGA? Isn't that what we really need? A more configurable, small, low-cost chip? I mean, we have this with, what have the processor vendors done is they've made silicon reprogrammable with sophisticated processors. Don't we just need the FPGAs to get a bit more sophisticated so you have programmable chips?
I don't think really the point of this is about low volume chips in a sense. I think the point of this kind of is more just getting a very large variety of building blocks and of potential tool solutions. Of course, there's economics of semiconductor. You've got to build some number of designs, and if it's a low volume, you're going to be pushed to FPGA or some configurable platform. But I think at the same time, if I'm trying to design a chip maybe for image recognition for a camera, there might be some kid in Czechoslovakia who has a great architecture. I'd sure like to get access to that, and he'd like to get access to me to buy it from him, right? And I think that's what we're talking about, is creating a world where we have a lot more content, a lot more variety of content coming from a lot more places, and somehow finding people that need it. Because I think we are going to see where a market might still be a reasonable volume chip. It's a chip that's kind of unique to that marketplace. You're not going to get that IP from Synopsys. It's something, or the tool from Synopsys maybe. It's some very special end need, even though you might make 1 million of them. And I think it's that variety we'd like to see.
It's not going to be just chips. The key here is not going to be just chips, systems, the prototyping, the entire system. We need to stop thinking as a community, stop thinking that we are the people that make the next node possible, and therefore we're going to have more chips that are going to be used in another more powerful phone or another more powerful switch or whatever. No, we're going to make billions of new systems that are going to be going out there, and the community is going to be able to do that in an effective way. That's what the challenge is, and I think thank you for listening and participating.